Hey, good morning, guys. Welcome back. We're doing a probability review. We only have one more week of school left, which is absolutely crazy. I had an absolute blast teaching you guys this year. I always looked forward to fourth hour, and if you guys ever need any help, definitely let me know. So let's get started on our review. So factorials are the product. Let's use blue. Let's use a dark blue. The product of a whole number and every whole number before it, but not 0. So 8 factorial, again, would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Same thing here, 4 factorial is 4 times 3 times 2 times 1. And I want you to actually type this into a calculator, get a full number. So this would be 24. This would be 5,040 times 8, which is like 40,320, I think. Maybe. But what I really want to focus on today is combinations. So we'll start with combinations. If I can choose from 3 paint colors, so paint 1, paint 2, paint 3. And with each paint color, I can have 2 interior colors. So here's interior 1, interior 2. And with each interior color, I can have 20 pairs of shoes. Or not 20 pairs of shoes. My goodness, wrong problem. 2 types of wheels. So wheel 1, wheel 2, wheel 1, wheel 2. So we can even count up, how many options do I have? So I have 2, 4, 6, 8, 10, 12. Or I could take 3 times 2 is 6 times 2. So 3 paint colors times 2 interior colors times 2 types of wheels. 3 times 2 times 2 gets me that same number of 12 options. 12 cars to pick from. So you're just going to look for your numbers here. 2 hats, 8 shirts, 3 pairs of pants, and 20 pairs of shoes. Then how many different outfits could I have? Well, it's 20 times 48. It's 960. It's 960 different outfits, or distinct outfits. Just to get some basic probability down, let's talk about rolling dice and flipping coins again. So, what's the probability of flipping a heads? Well, that's 1 out of 2. And rolling a 2 on a die, well, I can have 2 is my only option I really want. So it's 1 option out of 6 sides on a die. And we're doing the same thing here. We're just multiplying these together. So I get 1/12. So let's check out the next two. Flipping a tails is still 1/2. Rolling an even number, well, I could roll a 2, a 4, or a 6. So that's 3 options. That's 3 different possibilities of rolling an even number, 2, 4, 6, out of 6 total possibilities, 6 sides on my die. So 1/2 times 3/6 is 3/12, which is 1/4. And last but not least here, probability of flipping it tails is 1/2, and rolling a number smaller than 3. Well, what are the numbers that are smaller than 3 on a die? Well, it would be 2 and 1. That's 2 options. Out of 6 sides on a die, this is 2/12, which is 1/6. That's my probability. So we're always multiplying these together. And now we're getting into... Oh, those switched order. Now we're getting into the permutations. This is what we did yesterday. So this is an arrangement where order matters. This is when we were talking about arranging the letters in the word dinosaur. So, in the word dinosaur, how many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 letters to pick from. 8 letters. Alright, so 4, 5, 6, 7, 8. 8 letters. And how many options do I have in that first slot? I have all 8 to pick from. So that's 8 options to pick from. And now I've used one of my letters. So how many do I have left to pick from for my second position? Well, if I had 8 and I used one, I only have 7 left. Now for the third spot, I've used 2 of them. So I only have 6 left. And then for this spot, I've already used 3, so I've got 5 left. And so on and so forth. And then that last slot, I'm only going to have 1 letter left to pick from. It'll be the last picked letter. And you'll notice that this is 8 factorial, which is, I don't know, some number. I don't have my calculator with me right now. And you would type that into your calculator and get that big number and 40,320 or whatever it is. And that would be your final answer. So let's see. Number 6. I've got 7 students competing in a geography bee, whatever that is. And I want to know how many ways can I finish first, second, and third. So how many kids am I picking from? Well, 7 kids total. So how many kids could possibly win first place? Well, 7 kids could possibly win first. Okay, so that kid's out of the running for second. He's won first. But how many kids are left to pick from for second place? Well, I had 7. I've lost 1 because he has first place or she has first place. Well, then I can pick from 6 kids for second place. Now, 1 kid, she has first place. Second kid, he's got second. And how many students are left to pick from for third place? I've already used 2, so 5 kids are left. And I would multiply them together. So 42 times 5 would get me 210. So there are 210 ways that they could finish first, second, and third in that geography bee. All right, let's do a few more examples together. So Melanie's taking 4 classes. Okay, so 1, 2, 3, 4. She's got American History, Algebra 2, Best Class Ever, AP English, and Chemistry. How many ways can these 4 classes be arranged? So first hour, let's say, for whatever reason, the counselors like me, they're letting me choose what goes where. So first hour, how many classes am I picking from? Well, I've got 4 classes, so 4 classes to pick from for first hour. Now let's say I put Algebra 2 first hour, because I want to start my day off right. Well, then how many classes can I choose from for second hour? Well, I had 4, but I can't use Algebra 2 in first and second hour. That doesn't make sense. So I've only got 3 classes to pick from now, and so on. I've got 2 classes for my last 2 periods of the day, and my last period, I only have 1 option for that. Alright, let's do the next one here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 positions on a baseball diamond and 16 players. So how many players can I pick from for my first baseman, assuming they're all, maybe they're playing Little League or T-ball, where they really don't have any special skills yet. Well, I could pick from 16 different kids for first base. Okay, well, I've got my first baseman. How many kids are left to pick from for second base? I got 15 left. Now first and second base are filled. I got to pick a shortstop. So how many kids can I pick from for shortstop? That's 14. Now I've got a third baseman to pick. Alright, well, third baseman. I've already used 3 kids out of my 16. So 16 minus 3 is 13. What about my left fielder? Well, I've used 4 kids out of my 16, so I've got 12 left to pick from, and so on and so forth. I lose a kid every single time. And this would be, whatever this product is here, this would be the number of ways that I can arrange my team on the field. And here I've got 28 students in Mr. Miller's homeroom. And I want to know how many ways can students select a representative and an alternate. So it's 2 spaces. Somebody's going to be a representative, somebody's going to be an alternate, and you cannot be both. So I got 28 kids to pick from for the representative. 1 kid is gone now. 27 to pick from for the alternate. And this got kind of screwed up. There's one thing that we haven't covered yet that I want to do today. And this is just like arranging our letters in Dinosaur or Office or whatever it is. There's only one difference. What if I have repeated letters? So be on the lookout for repeated letters. So I'm going to count the number of letters just like I did before. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for automobile. So I've got 10 letters to pick from, then 9, then 8, then 7, then 6, 5, 4, 3, 2, 1, or you could call this 10 factorial. So how many letters do you have? I've got 10 letters. So that's 10 factorial. Now I have to divide by how many letters do I have repeated? So here I've got O repeated twice, so I'll divide by 2 factorial. So 10 factorial divided by 2 factorial. And now in 11, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So 9 factorial divided by. And now how many letters do I have repeated? Well, P is repeated twice, so that's 2 factorial. And A is repeated twice, so that's another 2 factorial. So that's 2 factorial times 2 factorial. Down in the bottom here. And, if, let's say I had a letter repeated 3 times, then it would be 3 factorial. If that letter is repeated 4 times, then I'd put 4 factorial. But in this case, it's just repeated twice, each one. And the reason why we have to divide this is because I've got, this arrangement. And I've got this arrangement. And the only thing I did here is I switched, this P went over here, this P went over here. But you'd never notice because they're the same letter. So we have to divide by that 2 factorial to eliminate my extra counting. I counted too many times. On this permutation formula, that would be how many letters do you have, how many objects do you have, over the repeats. So here, 10 factorial over what did I repeat? 9 factorial over what did I repeat? So, I hope you guys have a great day. As always, email me with whatever questions you got, and we'll see you tomorrow.